Hey guys, welcome to Math for Kids by a Kid. In this video, we're going to learn what logarithms are. So what are logarithms? Well, to know what logarithms are, we need to know what exponents are first. So many of you will know that exponents are ways that represent repeated multiplication. So here I have examples of that. 5 to the power of 3 means 5 times 5 times 5. So we're multiplying by 5 3 times. And same with 4 to the power of 8. We're just doing 4 times 4 times 4, 8 times. And then when you have a negative exponent, such as here, 5 to the power of negative 2, you simply move the term to the opposite side of the fraction to make the exponent positive. So in 5 to the power of negative 2, there's an invisible 1 down here. And then we just move this down below to make it 1 over 5 to the power of 2. And same below that, 1 over 5 to the power of negative 2, we simply move this to the top to make it 5 to the power of positive 2. So to answer our question, what are logarithms? A logarithmic function is the inverse of an exponential function. Now let's look at how we derive a logarithmic equation. So let's say we have the equation y equals b to the power of x. This is an exponential equation, and we want to write the inverse of it, which is the logarithmic form. So we're just going to swap x and y. So we have x equals b to the power of y. And we want to write this in the form y equals. So how we do that is we write y equals log base b of x. This is the equation of the logarithmic function. X is the argument of the logarithmic function. B is the base of the logarithm. And then y is the value of the logarithm. And we have a couple of rules about the values of the argument and the base. So the argument has to be greater than 0. And the base has to be greater than 0 as well. And it cannot be 1. So now let's practice converting from logarithmic form to exponential form. So let's try the first example. Log base 3 of 27 is equal to 3. So we know that 3 is our base, and this 3 is our exponent, and this 27 is the answer that we get. So we have base 3 to the power of 3 equals 27. Now the second example. 4 is our base, 2 is our exponent, and then 16 is our answer. So 4 to the power of 2 equals 16. And then I'll do the last two. You get the pattern now. 2 to the power of 5 equals 32. 1,000 to the power of 0 equals 1. Anything to the power of 0 equals 1. Now let's practice writing things from exponential form to logarithmic form. So 5 to the power of 4 equals 625. So 5 is our base. So I'll have log base 5. Then the argument is what we got as the answer from the exponential equation, which is 625. Then that equals the exponent on the base, which in this case is 4. Let's try the second example. The base is 10. Log base 10. The argument's the answer, 1,000. And that equals the exponent, 3. Next one, log base 2 of 8 equals 3. The fourth one, log base 3 of 81 equals 4. And there we have it. So now you have a good understanding of logarithms and how to solve them. And we're going to talk about one more thing here, which is called the change of base identity. So let's say we have to solve log base 4 of 1024. So we can solve this by figuring out what number 4 must be raised in order to get 1024, which in this case is 5. But now let's try something else here. Let's try doing log base 2 of 1024 over log base 2 of 4. And now we can solve each of these individually and then divide. So log base 2 of 1024 is equal to 10. And log base 2 of 4 is just equal to 2. And then when we divide them, we get 5. So in both ways, we got the same answer. So there's a relation here. So this is a change of base identity right here. So now if we compare it to the log we had before, we had log base 4 of 1024. That's equal to log base 2 of 1024 over log base 2 of 4. And this works for any base you want to have. Thanks for watching, guys. I'll see you soon.